All right, welcome to a video for lesson 37 on inequalities. All we're going to be doing in this video is a one-page lesson here. You should have a copy of these blank notes for yourself to work on, but what we're dealing with here are instead of equations, instead of working with linear equations, stuff like 6x plus 2 equals 21, where we're trying to solve for the variable x. Now, we are still trying to solve for the variable x, but instead of an equation, instead of an equal sign here, we're replacing it with an inequality, something like, less than or greater than or less than or equal to or greater than or equal to, something like one of these symbols here, all right? And what that means is that our answers are not single numbers. Like if I were solving this equation, I'll put the equal sign back here now. If I was solving this equation, I would subtract 2. I get 6x equals 19. Then I divide by 6, and x equals 19 over 6. X is one number, 19/6. That's what? 3 1/6. One single value. That's all that is. X can only be 19 over 6. In order for this equation to be true, x has to only be that number. When we're solving inequalities, what we're saying is that our answer comes from an entire range, an entire interval of values. Technically speaking, we're saying that the answer is infinite in many cases. All right, so that's the concept. More on that as we get working. So first of all, we got to make sure we know what these symbols mean. What does each symbol mean? This first one where the symbol is kind of the arrow pointing to the left, this literally means less than. All right, the next one means less than or equal to. All right, the next one is greater than. You got to memorize the direction of these. If you're still struggling, if you get to the point where you're working these problems and you can't tell the difference between less than and greater than, then you're going to struggle in this whole darn lesson, to be honest with you. And then the next one is greater than or equal to. Greater than or equal to. All right, notice the difference, obviously, between less than or equal to and just less than, and then greater than or equal to versus greater than. This little equal sign on the bottom means that our variable can actually equal whatever number we come up with. It doesn't just have to be less than that number. All right? So when we work with inequalities, we use a blank to show our solution. We use a number line or a graph to show our solution. The question is, why do you think that is? We use a graph to represent our solution because of what I just said. The solution is an entire interval of possibilities. We got a lot of numbers that x can be equal to. All right, well, while we're graphing, the rules for graphing are that when we have less than or equal to or greater than or equal to, you have a closed circle. You have a closed dot, like this one. Or if I'm being more specific, like that closed dot right there. If you don't, if you have just greater than or greater than or equal, or sorry, greater than or less than, then you have an open circle, an open dot. In fact, I'm going to make this pretty clear here by changing the color. So the open dot one is this one. All right, so it says, what's the difference between an open dot and a closed dot? What does filling the circle mean in terms of the solution? If the dot is closed, that means our value can equal that number. So this one is actually saying x is greater than or equal to 2. Whereas the one above is saying x is only greater than 2. How did I come up with the greater than? Well, the arrow is pointing to the right. The arrow is pointing to the numbers or the values that are larger than our boundary point of 2. The arrow is pointing to the right. Well, that means it's including all those positive values, all those bigger numbers, right? So greater than. All right, so we practice graphing a few down here. We start by plotting the point in question. In this case, the point is 2. So then we look and we go, okay, well, it's got a closed dot because of the equals to sign. So I have seen this done, and I have allowed it to be done in many different ways. I generally like to write mine above the line. So I will show it this way. I'll close the dot, and then since this is less than, I'm going to the right. I draw it above the line. All right, I'll move on to number 2. And number 2, I've seen plenty of students who like to do it on the line. And so they got stuff like this. This is -4. All right, so I'm at -4. And because there's no equal to sign, I'm going to leave my dot open. So open dot at -4, and then I'm going to the left. I see students do this sort of thing, and then add an arrow in the end. I've seen students that just do an arrow and try to make it bold enough. Whoop. Just do an arrow. I've seen students float the arrow just a little bit above. That's fine too. Any number of possibilities here, all right? But it does need to be an open circle, cannot be closed right here, and the arrow does need to be going left because it's less than, all right? On the next one, we start at 3. Here's another way that I've seen it. We start at 3, it's greater than or equal to, so instead of dots, a lot of times we use brackets or parentheses, a bracket for closed and parenthesis for open circles. I don't advocate that you do it this way, but you could do it bracket and then to the right. All right, again, I'm not going to do it that way because that's generally something we see in like pre-calculus or above. We don't necessarily see it here. So here it's just going to be a closed dot. I'm going to go back to my style. I like doing it above the line, and then I'm going to go to the right because it's greater than. All right, and then number 4 is 0. So I'm going to do open dot at 0, and I'm going to the right again. All right, so there you have it. Solving inequalities are solved. To solve inequalities, these were already solved. Number 1 through 4 here, these were already solved. Well, in this next group of questions, to solve an inequality statement, you treat it just like an equation. All right, they're solved just like an equation. You solve an inequality like you would solve an equation. There's only one little detail. When you divide or multiply by a negative, the inequality symbol changes. And I don't see one of those here, so I might be adding in an extra example. All right, so let's practice here. You solve it just like an equation. So the first thing I'm going to do is I'm going to add 8. Well, that gives me 2x is less than or equal to, and oh, look at that. -8 and 8 is 0 when I add them together. Don't be alarmed if that happens. -8 plus 8 is just 0. So these just give us the 0 here. Not a big deal. And then 0 divided by 2, 0 over 2, well, that's allowed. You can have 0 in the top, but you cannot have 0 in the bottom. So we have a 0 in the top. That's not a problem. 0 divided by 2 is just 0. So how do I graph that? Well, it's a closed dot at 0, and it's less than, so I'm going to the left. All right, moving on to the next one. Here I've got a +2. That means I'm going to subtract 2 from both sides. That gives me 3x is greater than or equal to 11 minus 2 is 9. And then I divide. 9 divided by 3 is 3. And now I've got a closed dot at 3. And the arrow is going to the right because x is every number greater than 3. So every number greater than 3. That means 3.001 would work. 3.001 would make this equation or this inequality true if I plugged it in. All right, and then finally, I'm going to start number 3 by adding 6 to both sides. That gives me 1/2 is less than negative 8 plus 6 is negative 2. I'm sorry, that should say 1/2 x is less than 1/2 x. And now in order to get x by itself, I'm going to multiply by 2 on both sides. And so x is less than negative 4. All right, so if x is less than negative 4, I'm going to find negative 4. I'm going to put an open dot, and then I'm going to go to the left because of the less than symbol. All right, so ignore the second page. That's not for you. It was for a little game, but I don't have that attached here. All right, so I'm going to add one little example in here about what happens, just in case you run into it, about what happens when you divide by a negative. So let's call this example 4. What if I have negative 2x plus 5 is greater than or equal to 7? That'll work. All right. So the first thing I'm going to do is subtract 5 from both sides. And so that leaves me with negative 2x is greater than or equal to 2. Then divide by negative 2. And because my divisor, because this number I'm dividing by is negative, I'm going to have to switch the inequality symbol. When I divide by a negative or multiply by a negative, the inequality sign will change. So that gives me x is less than or equal to negative 1. And notice the inequality sign changed. All right, then I go to the graph. Well, I want to graph it. Just for the record, if you're drawing the graphs from scratch on your own, which you will be in your homework, all I care to see is 0 and the number that we're focusing on. We're focusing on negative 1. Well, negative 1 is to the left of 0, so I'll put it here. I got a closed dot because of the equal to, because it's less than or equal to. And then I'm going to the left. To the left. All right. There you have it. You'll see plenty more examples of this. We'll build on this concept. I'm sorry there weren't more of these in your notes, but for now, I wouldn't worry about it. We'll see more as we go. All right. Hopefully you got something out of this. Thanks.